Okay, for the first assignment, the basic statistics review, one of the things I asked you to do is calculate the percent change. And the reason for doing that is because it's a really great way to compare things without having to mentally calculate the difference between these numbers. So what we're looking at here are the decadal averages in carbon dioxide emissions in megatons. So by region, Africa increased their CO2 emissions between the two time periods. Asia increased, Central America increased. The only group that saw a decrease was Europe. Okay, everything else is an increase. So we're going to be calculating a percent increase for all these. Now, it's a way of normalizing and being able to quickly compare to kind of provide this common denominator of percent. So the percent change versus having to kind of mentally tabulate these. That's the whole point. And it's a really good habit to get into, to think about not providing just raw values, but what does that actually mean? So calculating percent change over time. So we've already talked about how they should all be a positive. And then the way to think about percent change, this one is a good example. 24 to 48 is a doubling. This is a 100% change, a 100% increase because it doubled. Does that hopefully make sense? If so 850 goes into 4400, less than 5 times, more than 4 times. So this would be a 400% increase because it's like it's like 4 times greater. Yeah, this is going to be over 3 times greater, so a 300% increase. Those are the ballpark numbers that we're looking for. A 100% increase is a doubling. Okay, so let's just walk through this. I know my instructions completely stunk. Percent increase, the change between the two values divided by the original value, in our case the earlier one, multiplied by 100 to make it a percent. Okay, so we're going to be differencing the new value, subtract the old value, divided by the old value, the original value. Okay, that gives us the difference. It doesn't matter what order you do this in, as long as you're keeping track of the positive or negative change. The difference, the absolute value between them is going to be the same. So you just need to keep track of the positive and the negative sign. So for that first example, 362 megatons, subtract the original value, 108 megatons, and then divide it by 108. You get 2.35, multiply it by 100, and you get a 235% increase, which is about right for these. Okay, that's it. If you have any questions, please let me know.